The number 6174 has been called the most mysterious of all numbers, which seems to me exaggerated and not very rigorous. Let's see, if there are infinite numbers, how do you know he is the most mysterious of all? Have you looked at them all and are the others less mysterious? Although to be fair, the truth is that 6174 is a very, very curious number, with a surprising property that we still do not know if it obeys some deep reason. Has curiosity piqued you? Let's go check it out. Choose a 4-digit number that is not all the same. Whatever it is, choose without fear and write it down on a piece of paper. For example, choose 1121. Now form the largest number you can form with those figures, and the smallest, and subtract them. In my example it is 2111 minus 1112, which gives 999. If he gives you a number of less than 4 figures like he gave me, complete it with zeros so that it still has 4 figures. I'm left with 0, 9, 9, 9. Okay, now the same as before. You know, the largest possible number with those 4 figures, minus the smallest. I get 9990 minus 999, which is 8991. And keep repeating that procedure all the time. I have 9981 minus 1899, that's 8082. I repeat again and it comes out 8820 minus 288, 8532. That if I do it again, I have 8532 left minus 2358, 6174. Here it is. I got the 6174, you too. Well, unless you've done some wrong subtraction, you have to get 6174. And that's part of the mystery. No matter where you start, you get to 6174, it always happens, which is pretty freaking out. But notice that if you do the same procedure with the 6174, what happens? For that 7641 less 1467, gives 6174. It is impossible to escape. Once you get to 6174, you stay there forever. If we call the Capricar process this of taking the largest number you can form with those figures and subtracting the smallest, then we can say that 6174 is a fixed point of the Capricar process for 4 figures. This very rare thing was discovered by Dattatreya Ramachandra Capricar in 1949, and that is why 6174 is known as Capricar's constant. Capricar was an Indian mathematician expert in recreational mathematics and discovered other types of numbers quite crazy, which maybe I'll talk to you another day. Capricar numbers, Karshid numbers, which in Sanskrit means great joy, and Otto numbers, also called Colombian numbers. Capricar not only showed that this procedure with the 4-digit numbers always reaches 6174, but at most you will need 8 steps. Look at this very beautiful figure color codes the number of steps you need to get to 6174 from each number from 0 to 9999, completing with zeros when necessary. I would call it Capricar carpet, and I would like to have it in my room as a tribute. Very nice everything, isn't it? But what about other digit numbers? Is there also a Capricar constant for 3 figures? And for 2, or 5, or 27? This happens with 3 figures. 495 has the same behavior, that is, it is a fixed point of the Capricar process for 3 figures, and everything except numbers with all the same digits, ends in 495. So it is Capricar's constant for 3 figures, which moreover is always reached in 6 steps at most. For 2 figures that does not happen, there is no one number to which everything falls, but a cycle of 5 numbers. That is, sooner or later you fall to one of these numbers, 0, 9, 81, 63, 27, 45. And you don't get out of there because one leads to the other and you end up in a cycle. And that's what happens from then on, that you find cycles or fixed point or both, but there is no number of figures that has a single constant, that is, a single fixed point to which it will give everything. For example, for 5 figures there are 2 distinct cycles of 4 numbers and another of 2 numbers. For 6 figures there are 2 fixed points and a cycle of 7 numbers. If it's cool for you to play with mathematics, I propose a problem that is simpler than it seems, although you have to work on it. Proving that every number of the form, a 6, a bunch of 3s, a 1, a 7, another bunch of 6s, exactly the same 6s as 3s, and a 4, is a fixed point of the Capricar procedure. For example, this right here. Do you see how they are formed? I really don't know if all this cool stuff is for anything. It's recreational math. Of course, you can use it in class to practice subtraction, beyond putting lots of worksheets. You give the class any 4-digit number and see who gets to 6174 first and in how many steps. If one does not arrive or arrives in more than 8 steps, it is that he has made a mistake. It corrects itself, teachers. I send you 6174 hugs.